Welcome to the fifth and final lesson in our current unit. To begin, we're going to factor some equations like we would have back in algebra class. Here we've got a common factor of x. So we can factor out x. And then we would set each term equal to 0. By that I mean each factor equal to 0. Add 1 and divide by 2, and we find that x is 1/2, or 0. Now this equation here factors in the exact same way as we'd factor that equation. We've got a common sine of theta in each term, and then what's left behind? 2 sine of theta in the first term, and then minus 1 in the second term. And that's equal to 0. See how that's essentially the same structure as we had in the previous example. So then we set both of these equal to 0. Add 1, divide by 2, and we get that sine of theta is 1/2, or 0. So then we have to ask ourselves, what is the angle? So we're solving on this interval 0 to 2 pi. And so I look at a graph, a sine graph from 0 to 2 pi. 2 pi is here, pi is here, 0 is here. Goes up to 1, goes down to -1. So then, what angles have this sine value? Well, we have one right there, there, and there. So this would be at angle 0 radians. There's pi over 2, there's pi, there's 3 pi over 2, which of course isn't one of them. Then here's 2 pi. Now our interval is from 0 up to 2 pi, but not including 2 pi, and so we don't include that one right there. We just include 0 radians and pi radians. Next, 1/2 isn't easily visible, distinguishable on our sketch graphs. So we draw some reference triangles. Y over R, that's a 1√3/2 triangle. Y over R, √3 for that side. And the angles that generate this are a 30-degree angle and a 330-degree angle, because that's a 30-degree angle in there. In radians, those are pi over 6 and 11 pi over 6. And so there's 4 different solutions for this equation right here. Next pair. Let's factor the equation up top. It's a quadratic, and so we'll factor it into 2 binomials. X minus 2 times x plus 1. And so this cosine equation is identical in structure. Cosine of x minus 2 times cosine of x plus 1. And if you FOIL it, you see that you would end up getting what you started with. Set each of them equal to 0. Erase the really messy 2. Then add 2 to both sides. Take away 1 from both sides. And then ask myself, which angle has a cosine value of 2? Well, looking at the cosine graph from 0 to 360, or from 0 to 2 pi, the max that it reaches is 1. The min that it reaches is -1. Therefore, there is no angle that has a cosine of 2. Next one, where is the cosine -1? It's -1 halfway through the cycle of the graph. The cycle is 2 pi length, and so pi radians is the only solution on the given interval. Next up, we need to use identities to solve this one. So then, first off, we've got sine squared and we've got cosine. We've got two different trig functions, and so we're going to want to convert either this cosine into a sine somehow, or this sine into a cosine somehow. Now, we don't have any trig identities that directly relate cosine into sine, but we do have a trig identity that relates sine squared into cosine squared. And that is the variation of the first Pythagorean identity, which tells us that sine squared is 1 minus cosine squared. So then we sub in place. Then I'm going to use the distributive property here. Now, since I'm trying to solve it, I'd like to have a 0 over on the right side. So I'm going to subtract 1 from this side and from the other side. Then I'm going to reorder this so that we've got our highest degree term at the front. Next, we see that we have a trinomial, and so we're going to try to factor this into a pair of two binomials. It's easier to factor when we don't have a negative in front of our leading term. So I'm going to factor that -1 out. Now I'm going to take what's inside, which is still a trinomial, and I'll try to factor it into a pair of two binomials. To do that, we need to do 2 cosine of t times cosine of t, and that would get me the first term. My last numbers need to have a product of -1. This fulfills it. Then if I check my work using FOIL, I would see that the middle term also checks out into plus cosine of t. Now what I can do is I can take each of these factors and set them equal to 0. First, this negative symbol, -1, set equal to 0. Of course, that doesn't lead to any solutions because it's false. Then set that second term equal to 0. And then the third term, third factor I mean, equal to 0. So we'll take this one, add 1 and divide by 2, and we have the cosine of t equals 1/2. Then that was supposed to be 1 there, as you saw here. Subtract 1 from both sides, and we have cosine of t is -1. So then we ask ourselves, which angle or angles have a cosine of 1/2 or of -1? Let's do this 1/2 first. Cosine is +1, radius 2, that would have to be √3. So then you've got a 60-degree angle across from the √3. Second such triangle would look like this. There'd be a 60 in there as well. So then the two angles would be 60 degrees here, which is pi over 3. And then this angle here, taking us from the positive x-axis to that radius, and that would be 300 degrees, which in radians is 5 pi over 3. Last, how about this cosine of t is negative 1? That's a quadrantal angle, so we'll look at our cosine graph. 1, 2, 3, 4. Fourth one is here. At pi over 2 it hits 0, and at pi radians it hits negative 1. And so pi radians is the third solution there. Last example. Alright, we can use our calculator towards the end of this problem. First thing I'm going to do is sine and cosine it out. And so that'll be sine of x over cosine of x equals 3 sine of x. Next what I'm going to do is I see that let me put it this way. One of the things we like to do when we're solving equations is to have a 0 on one side, because then if we factor it, we can set both of them equal to 0. So let me subtract 3x from both sides. I'm going to save myself some writing. Subtract 3 sine of x from both sides, and it's going to look like that. Next, I see that I've got a common factor of sine of x in both terms. So I'm going to factor that sine of x out. Now I can set both of these factors equal to 0. Sine of x equals 0, and then 1 over cosine of x minus 3 equals 0. Then I'm going to add 3 to both sides here. Now I need to find out what cosine of x is. So I'm going to multiply both sides by cosine of x to get it out of the denominator. And then I'm going to divide both sides by 3. Okay, so then we ask ourselves, what are the angles that make each of these equations true? So go to my sine graph. Sine goes like so, from 0 to 2 pi. Of course, it crosses here at 0 degrees, and here halfway through should be at 180 degrees, or pi radians. Next up, when is the cosine of x 1/3? Well, there's no easy triangle that's going to get us 1/3 as a cosine. So what we can do is we can go to a calculator and do the cosine inverse. When you do the cosine inverse of 1/3, make sure that your calculator is in radian mode, because our interval is described in radians instead of degrees. When we do that, we see that we have 1.2310 radians. Let me pause here just a moment. So there's one more solution in addition to the one that the calculator gives you, but since we're almost up to the 15-minute mark on this video, I'm going to have us finish up where we are, and we'll take care of that last one in class. And so I'll see you there.